I am Ceren, and I am a PhD student in Eindhoven University of Technology. I am working with Joaquin Vanschoren under AUTOML group. I am excited to share with you our work called Adaptive Regularization for Class Incremental Learning. Before we delve into the details, let's take a moment to understand the context of our research. Within continual learning, class incremental learning is a specific scenario where it involves updating a deep classifier with new classes while maintaining accuracy on previously learned classes. However, in the process of learning new tasks, there is a challenge we must overcome, which is catastrophic forgetting. This phenomenon occurs when our models forget the knowledge of previously learned classes while learning the new ones. The incremental learner aims to learn the current task effectively while maintaining performance on previous tasks. This is achieved by optimizing a function, combining standard cross-entropy for classification with a regularization term. The regularization penalizes sudden changes in the neural network weights, and the balance between the two is controlled by the hyperparameter lambda. Two non-regularization approaches are parameter regularization and knowledge distillation. Elastic weight consolidation is an example of parameter regularization, which identifies the crucial parameters for all tasks and penalizes updates to them during learning the new task. Learning without forgetting is a knowledge distillation method, involving learning from a pre-trained teacher model to preserve knowledge of old classes when learning new ones. However, traditional regularization techniques use a constant regularization magnitude throughout the learning process. Building accurate lifelong learning machines requires dynamic adjustments of lambda based on the task novelty and similarity. However, we propose that this constant regularization assumption is unrealistic. Imagine an incremental learner encountering a familiar object like a dog after observing cats. Here, lowering the lambda is unnecessary as knowledge can transfer quickly. But if it encounters a novel object like a car after animal categories, lower lambda and higher plasticity are needed to learn about the unfamiliar parts. In our approach, the regularization magnitude lambda is dynamically determined considering the current and all previous tasks. We define lambda t specific to each task, and it is predicted by minimizing the following optimization problem. Here, Vt is the subset of the validation set that includes the current task and previous tasks. The optimum lambda for each task is found using 3% estimators by minimizing the loss function. This approach allows us to automatically adjust the regularization strength according to the specific learning task, enabling more adaptive and effective lifelong learning. We validated our approach using Cypher100 and MiniImageNet dataset, each split into 10 tasks with 10 classes per task. We implemented our adaptive approach on top of two well-established methods, EWC and LWF. In the vanilla versions, we kept lambda value fixed, while in the cosine versions, we decreased the lambda value at each learning step. We evaluated the performance using two metrics, incremental accuracy, which measures the final accuracy averaged over all tasks, and backward transfer, which measures the average accuracy change of each task after learning the new ones. Results on the left side of the slide displaying that across all methods, adaptivity showed a remarkable increase in top 1 accuracy compared to all baselines. The table on the upper right side shows that adaptivity had a more substantial impact on accuracy and backward transfer, specifically on EWC method. Our intuition is vanilla EWC is more prone to forgetting compared to LWF method. In the figure on the right side, we demonstrate our method's ability to adjust the regularization magnitude according to the learning task. This highlights that a fixed regularization scheme is unnatural and explains the superior performance of adaptive approach. To sum up, in this paper, for the first time, we raise the important issue of adaptive regularization in class incremental learning. We propose to predict the regularization magnitude automatically, conditioned on the state of the deep learner and the current learning task. And finally, we show that learning adaptively yields significant performance improvements in terms of increasing accuracy while reducing forgetting. Thank you.